Alright guys, so we're back again, and in the last video we took a look at this same IP address, and we were moving away from the /24 and the /16, right, and 8, and those octal boundaries, right, these perfect, nice and easy IP addresses, right, and now we're looking at it going, I said, hey, you know, let's take a bit away from the host portion of our address, that's /24, and let's make it a /25. So we went through the whole process and we actually found that we chopped the network in half, right? We had the /24, and by making it a /25, we made it smaller, all right? And a key thing I said there, we chopped it in half, right? If we take a look at this here, just a little side note, right? 2 to the 8th power, right, with my 256. Now, we know minus 2 for a usable range, but 256. 2 to the 7th power, right, is 128. Okay, what happens if I divide my my 256 by 128? Right, I get 2, right? Or 2 times this value is 256. So essentially, a /25 cuts my /24 in half, right? And so if we have a /25 cuts it in half, what would a /26 do? Think about that. We'll go through this whole problem and you'll see what happens, right? I'll leave that there. All right, so /26, let's go through the ANDing process again. This is getting repetitive, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26. 1, 2, 3, 4, 5, 6. Whew. Okay, 255, 255, 255. That's different now, right? The first time it was 128. Well, this column, if we do our binary table, right, is 128, and that one's 64, right? We also see up here, right, 1, 1, and 6 zeros, 1, 1, and 6 zeros. It's 192, right? Or 128 plus 64 is 192. All right, so my subnet mask value is 22255.192. All right, and now I can go through the ANDing process to find my network address once again. So here we go, my network address. All right, now again, we've seen this time and time again. I'm not going to write out all the binary. It's getting to the point where this is pretty repetitive. So a 1 and a 1, this is 192. All right. All right, this is 168, and this is 50. Okay. But we can see here, all right, that my address, again, this is my boundary. This is my new boundary right here. Try to make this straight as possible. Okay, so I've got a 0 and a 1. All right, nothing's changed there. But now I've got a 1 here and a 1 here. And now I've got 6 ones my hosts. 6 zeros. 1, 2, 3, 4, 5, 6. All right. So what's that? This whole octet. Don't forget, you have to include the whole thing. Now I might only have 6 host bits, but I have 8 bits total in my octet. 0, 1, and then 6 zeros. What is that? It's 64. So Andrew, you mean to tell me that .0 doesn't have to be a network address? You're darn right it doesn't. All right. This is why I didn't want to. You will hear people get into saying we always start our network at .0. Not always. I've heard people say that before, so I didn't want to give you that information because here's our exception. All right. Because 90. Right, because 90 is written this way. If my address was 192.168.50.30, right, that would be a 0 right there. That bit would be a 0, all right, because that's 64 and 30 is less than 64, so I wouldn't have put a 1 there in that bit position, all right. So it would have been a 0, and then my output would have been a 0 down here. Because it's a 90, I've got a 1 here. And then when I go through the ANDing process, 0, 1, and 1, 1 in the subnet mask gives me a 0, 1 in my network address. All right? So we have this. We can continue on throughout the rest of the process. All right? So let's go out and let's grab our broadcast address. Hunker on down again. And I'm going to grab my broadcast here. Put my broad there. All right, my 192, 168, 50 dot. All right, and these values come back down again. So these guys come down here, right? 0, 1. And then once again, we flip our host bits. 1, 2, 3, 4, 5, 6. All right, and then we take the entire thing and we find the decimal equivalent, which in this case is 192, 168, 50 dot. We had this last time, 0 and then 7 ones, 127. All right, so there's our broadcast address. So our range starts at 64, all right, and it goes to 127. So based on this value, pretty easy for us to find the first and the last, right? Our first and our last. Once again, plus 1, minus 1. That's the same, that's the same, that's the same, right? Plus 1 from 64, yeah, you guessed it, 65. And plus or minus 1, sorry, from the broadcast is 126. Okay, so my range here is this address. Now, the range that this address exists in, that's an important key here, all right? The address that was given was 192.168.50.90/26. All right, so the range that this exists in, if my notation says my subnet mask is a /26, is I'm going to have 192.168.50.64, and I'm going to end somewhere around 127. We can see that, right? This 90 is somewhere in here, right? It's somewhere between 65 and 126. So this is legitimate. This is the real network, okay? So once again, I had 6 host bits, right? So actually let me take this here. Let me get rid of this thing over here. Okay. All right, so again, 2 raised to the 6th. Well, that is, 2 raised to the 6th is 64. All right. And then, of course, minus 2, we have 62 total usable addresses, 65 to 126. 64 is the network, 127 is the broadcast. All right. If this was a Class C, right, remember, originally we had our Class C network, right? 2 to the 8th is 256, all right? If a slash, and this was a /24, this is a /26, all right? Our /27 was in here, all right? And if our /27 was 2 raised to the, actually, let me bring this down so we can see this unfold, because this is going to be the key coming into our actual subnetting when we break down our networks with what we call variable length subnet masks. All right, we really start to break this down. Okay, let me grab some different colors here. 2 to the 7th is 128/25. All right. 2 to the 6th equals 64/26. All right. So, all right, this is the pattern we're starting to see. So we can see that in our pattern, right? If this was if we started with a /24, right? That's a 4, not a 9. /24. All right. Those colors don't jive very well, do they? No, these markers, you can't really write on top of them with each other. It don't really work that well. All right, let's try to make a real 4 this time. There we go. Okay, /24. Okay. This was our base value. This is where we start, right? This is the base. That's where we started. And then we said, let's move one bit over. Let's take a bit away from the hosts, my 8 host bits, and give it to the network. So we now have 7 host bits and a /25, right? And that gave us 128 total hosts, or 126 usable, right? And if we took that 256, right, our total, our /24, and we divided it by that 128, we can see we have 2 networks, right? We could actually make 2 smaller networks, right? And if I take my 256, divide it by 64, I get 4 smaller networks. Now that's interesting, all right? So what we're going to start to see, you can start to see this pattern where every time we grab a bit away from the host and we give it to the network, all right? You know, let's say, right? Let's say we have 2 raised to the 5th, right? We grab another one, /27, all right? That's 32, all right? That's 32 divided by 256. That's 8 networks, all right? So every time we grab a bit away from the host network and we give the hosts and we give it to the network in this /24, right? We're going to double the number of networks we have, right? We have 2, then we have 4, we have 8. We keep on doubling, and then we keep on having the size of our networks. They keep on getting smaller and smaller and smaller. Okay. Another thing that we can notice here, kind of running out of space, but another thing we can see here is if this was, you know, if our classful boundary is a /24 here, all right, /24 classful boundary, all right, if that's our classful boundary, all right, and we have 2 here, so we have 2 to the 6 as our host bits. That's 64 per network. And then we have 2 to the 2nd. We have 2 more network bits here. That's 4 networks. So we can see here, right down here, that given a /24, if we have 64 hosts per network and we have 256 total, we get 4 total networks. Or you could do some do the math another way and look at it and say, well, if I have 6 host bits, that means in a /24. This is assuming that we're operating, you know, extending beyond this Class C network. We have 2 to the 2nd power, or 4 networks of 64. All right, that's really going to start to come in handy. And we're going to take a look at that in the next couple videos here. All right, but before we do want to give you an example of this looking at a Class B network. So a network, we've been going in this direction, right? We've been going this way. What happens if we make that a 0? All right, what happens if we make an address a /23? What happens? Well, I'll show you guys in the next one.